Last time we talked, we worked with graphs. We tried to actually see literally when we approach from the left, from the right, where is our function heights going? Where is the actual values going? What is our L value that we're trying to approach? We did limits visually, graphically. Today we're going to do something different. We are going to solve limits a different way. And Unit 1, keep in mind, is all about solving limits. This way we're going to do it is actually by plugging in numbers. We use a table with x coordinates and y coordinates, and we plug in the x coordinates to see where the y coordinates end up going close to. All right, let's just do a quick review. What we are saying verbally with the limit, as x gets close to a, what we want to do every single time we have a limit problem, we want to see where does f of x go. That's it. That's all we are doing. As x approaches a, where's f of x going? What value is it getting really, really close to? Remember, we have to do it from the left-hand side and the right-hand side to figure out what the two-sided limit equals. So, the way we do it this time is by this table. We're going to estimate if we take points that get closer and closer to the point we're trying to approach, that x equals a point, where are the function heights getting close to? Well, let's just plug in points to figure this one out. Well, in this case, the limit as x approaches 2 is what the problem has given us. So what we've done here is we have a table of values that get closer and closer to 2 from the left-hand side, the negative side, the smaller side. And we also have values that get closer and closer to 2 from the right-hand side. This is simulating x going to a from the positive side. And this is simulating x going to a from the negative side. So now what we do is we plug in values, plug in x values into the function to see if it kind of starts to tell us where the function is going. Because remember, that's all we're trying to solve with limits. Where is the function going as we get close to some number? So let's plug some stuff in. You can use a calculator to verify this. The answers here are 3.9, 3.99, 3.999. So when you plug in 1.9 into our function, you end up getting 3.9. When you plug in 1.99 into our function, then you get 3.99. And likewise with 1.999. So if we do it on the other side, we're going to get 4.1. If we plug in 2.01 into our function, what we get is 4.01. And if we plug in 2.001 into our function, we're going to get 4.001. So as we got closer and closer to 2 by plugging in values that are closer to 2, take a look what's happening to our function. 3.9 is pretty close to 4. 3.99 gets closer to 4. 3.999 gets really close to 4. What seems to be happening is from the left-hand side, our limit is approaching 4. And 4.1 is quite close to 4. 4.01 is even closer to 4, and 4.001 is even closer to 4. So from the right-hand side and the left-hand side, they both seem to be approaching 4. So we can estimate, since our left-handed limit goes to 4, and our right-handed limit we can estimate goes to 4, well then the two-sided limit we can estimate to go to 4, and indeed, it does go to 4. So go ahead, take these two graphs and try and figure out, using the numerical tables, where is our function going as we approach some certain value. All right, welcome back. This one right here, as we get closer and closer to 3 from the left and right hand side, we see that our function values start to hone in on the number 7. It's getting closer and closer to 7. So we estimate that the limit as x approaches 3 of h of x equals 7. And for our k of x function, what we have here is as we get closer and closer to 3, k of x from the left-hand side gets really, really close to 2. And from the right-hand side, from the positive side, as we get closer to 3, k of x seems to be getting close to 5. So what does this mean? Well, from our last video, we discussed that the left-handed limit and the right-handed limit both have to equal if there's two-sided limit is also going to equal. And if they don't equal, we say it does not exist. So in this case, we estimate that it does not exist. And that's it for solving limits numerically using a table. Next time, we're going to do some more analytical ways to solve limits, but the goal is always to be solving different techniques to solve limits.